Okay, now we get into some application problems. They're really not too bad. You just have to stay organized. So Bob, who apparently only carries coins around, he paid for his lunch with 124 coins consisting of pennies, nickels, and dimes. Numbers of nickels is equal to the number of dimes plus the number of pennies. How many coins of each type did he use? Okay, so we really do have three equations in here, and I'm going to start with the simplest one. And let's use P for pennies, N for nickels, and D for dimes. So the number of pennies plus nickels plus dimes, they tell us, is 124 coins. And they also tell us that the number of nickels is equal to the number of dimes plus the number of pennies. Now, we want this in what we call standard form. I'm gonna subtract, so this is my equation 1. I'm gonna subtract N, so it looks like the other two equations, and I get negative N plus P plus D equals 0. That's my second equation. The third equation is kind of interesting. We're just gonna talk about how many pennies, nickels, and dimes it took them to pay for $6.24. So a penny is worth 0.01 cents. So 0.01 times the number of pennies will give us how much he paid in pennies. Likewise, 0.05 times the number of nickels, and plus 0.1 times the number of dimes is how much of that bill he paid for in dimes is equal to, I'm just going to drop the dollar sign, $6.24. Now, when I worked with this problem, I did not like working with those decimals, and there's a really easy way to clear those decimals by multiplying everything by 100. That'll get me, I'm working with integers, which will help me to eliminate. Trying to eliminate with decimals is horrible. So 100 times 0.01, that's 1p. 100 times 0.05 is 5n. And then I multiply 100 by 0.1, I get 10. D is equal to 624. So there's my third equation. Now let's look at equations 1, 2, and 3. And it looks like I didn't write 1 in the right order. Let's go fix that. Let's get everything in the right order. So we subtracted n, so we get p minus n plus d. Okay. So if we put equations 1 and 2 together, we can eliminate n's, and then I can multiply equation 2 by 5 and put it together with 3 to also eliminate n. So let's do it that way. P plus n plus d equals 124. That's my equation 1. And equation 2, p minus n plus d equals 0. So I get 2p plus 2d equals 124. All right, I'm going to take equation 2 and I'm going to multiply it by 5. And that's going to be equation 2 prime. So I get p minus n plus d equals 0. 5p minus 5n plus 5d is equal to 0. And let's combine that with equation 3, the modified equation 3. P plus 5n plus 10d is equal to 624. 6p. N's go away, plus 15d equals 624. All right, let's take a look at that equation and see what we have to do to eliminate either p or d with equation A. It looks like if I multiply equation A by a negative 3, I'll be able to eliminate p's. Okay, 124 times 3 is 372. Okay, so let's stack and combine, see what we get. And that should be a negative 372. Keep making that kind of error. Okay, negative 6 plus 15 is going to give me 9D, and 372 minus 624 is 252. And when I divide 252 by 9, I get 28. So D equals 28, and I'm running out of room to work backwards, but we'll start with equation B, 6P plus 15. If D is 28, 624, we'll be able to solve for P. 15 times 28 is 420. Subtract 420 and divide by 6. P equals 204. 204 divided by 6 is 34. Okay, and go up to one of the easy equations. P plus M plus D equals 124, and I'll use this room here. So we know that D is 28 and P is 34. Plus N plus 28 equals 124. So when we subtract 34 and 28 from 124, we get 62. All right, so N equals 62. And there's my 3 answers to that problem. Okay, stop this video. See you on the next one.